So use the graph of the square root of x to graph y minus 2 equals negative root 3. So first of all, I'm going to change my equation to match what we need to have happen. We have a horizontal stretch, compression, and a horizontal translation, so we have to factor it out, and we move the 2 over to the other side. So now we can label things. What's this negative going to do? It's going to multiply y by a negative 1. And by doing that, you're going to reflect it over the x-axis. The 3 is going to multiply x by a third. 1 to the left, and up 2. Now we think of our parent graph, and what are going to be some key points on our parent graph that we're going to label? Well, for sure, always 0, 0. That's going to be a key graph, key point. As far as wondering how many points do I need to label, for this one, 2 points would be enough. Because if you have 2 points and you have the right shape of your graph, you're going to get full marks. If you think 2 points won't be enough for you, that you'd like to add a third one, you can. But in this case, I need to multiply x by a third. Can you think of a point on our original graph that that's going to work out nicely with? This one right here, 9, 3. When x is 3, the y value isn't very nice. So this is the only nice one that divides nicely by 3 that also has a nice y value. After this, the next nice one would be what's that? But square root of 18 unfortunately isn't 6. 4, 2 are nice numbers, but they don't, when you divide by 3, then you're going to get fractions. It would be like, I think 81, 9 would be the next nice one. So if you want to focus on that point, I'll label it. There you go. All right. That's about where it would be, you think? Maybe?
Actually, yeah. I could see it.
Yeah? Maybe it should be a little bit further. Okay. Anyways, we're going to take these 2 points. We've got 0, 0. And we've got 9, 3. And we're going to look at what happens, and we'll do it in 2 steps. We'll do all of our stretches, compressions first. So what gets multiplied? The y's get multiplied by negative 1, and the x's by 1/3. And then we'll move it left 1, up 2. Love multiplying by zeros? Yes. And here, when we multiply the x by 1/3, we get 3. The y by negative 1, we get negative 3. So be careful here. Can you see yourself accidentally mixing them up and multiply? You say x by 1/3, but you multiply the y? Something like that. Simple mistakes just from not focusing. That could happen. Now we're going to move left 1. If I move left 1, I'm going to be at minus 1 and 2. Up 2 is going to get me to 2 and negative 1. So now looking at our final graph, we have the point negative 1, 2. And 2, negative 1. Now this is where drawing 2 points can be dangerous, because you have a choice now. You could either curve it down this way or curve it this way. Both of those look somewhat like our regular square root. Which is the one that's going to be the right one? So which one's curving it down? Like this? Now, when you're asking yourself which one should it be, what you do is you do these kind of transformations in your head without points. Don't worry about specifics. But if I multiply y by -1 and I flip it over the x-axis, can you see that this would look like that? And then if you multiplied x by 1/3, it's going to get wider and look like that. Then it's going to move left 1 and up 2. And you get an idea for what your graph is going to look like. But the important part is we know that it's curving like that, not like this. So because of that, we know that this is our final graph, and we're done. Okay, questions 8 and 10. What's the domain and range of our final graph here? Our domain, x has to be bigger than or equal to -1, and our range, y is less than or equal to